Good morning, class. Here's Math 119A, Chapter 1, Sequences, Section 1.6. Sequences and difference equations. We are going to finish up the section. Here's example 6. Pacific salmon populations have discrete breeding cycles in which they return from the ocean to stream to reproduce and then die. This occurs every 1 to 5 years, depending on the species. Then it explains how it happens. In part A, suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with probability D. After swimming upstream, each fish produces B offspring before dying. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. What is the discrete time recursion for the population dynamics, assuming that there is no mortality while at sea? You should count the population immediately before the upstream journey. In the second format, suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. What is the discrete time recursion for the population dynamics? Again, assume that there is no mortality while at sea. In part C, it wants to compare them. So let's get started with part A. What I want to do, I want to reread part A and tell you how we start with that. So suppose that each fish must first survive predation by bears while swimming upstream. How many fish do we have to begin with? X, Y, Z, N. We're going to call it N sub T. So that's in the beginning. So predation happens with the probability of D. And so in the second part, after they swim upstream, predation takes place. We call it N sub P, which is this one minus the number that are gone, which is D times that, because D is the percentage that is taken away by the bears. So N sub T minus D N sub T. In other words, if you factor this, you get 1 minus D times N sub T. You want to pay attention to this. Sometimes you can come from here to here just by understanding the concept. Again, understand. Let's say D is 20%. That means 1 minus D, 80% is left. The next step, so after that, so after swimming upstream, each fish produces B offspring before dying. So basically, the next one, you just multiply this one by B. To understand this, we're going to say N sub P plus B times N sub P minus N sub P. Because whatever we have here, all of them will die. So simply put, multiply this one by B. Finally, the stream is then stocked with M additional newly hatched fish. So we add M. So whatever this number is, we add M. That's it. This is for part A. The synopsis of that, in part A, predation takes place while swimming upstream. So we have N sub T to begin with. If D is the percentage portion fraction that is gone, 1 minus D is left, 1 minus D times N sub T. Then when they go up there, they create B offsprings and they die. So simply put this one times B. And then we add so many. How many? M. We're done with part A. Part B. Suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. So again, how many do we have to begin with? N sub T. Same size. Then each one give us B offsprings before dying. So B times that. Now that I explained the previous page, I'm going to just make it just B times that. Then what happens? We add, the stream is then stocked with M additional newly hatched fish. So add M BNT plus M. Now, at the end, all fish face predation with probability of D. So if D is 20%, 80% is left. Is these 40%, 60% is left. So this one times 1 minus D. Remember, D is a proportion, is a portion, is a fraction, and it's between 0 and 1. Can it be 0? Yes. Can it be 1? Yes, but normally somewhere in between. So now the question is, which of the recursions, part A or part B, obtained in parts A and part B, predict the largest increase in population size from one year to the next? Justify your answer both mathematically and in terms of the underlying biology. You can assume, of course, D is between 0 and 1. That means a positive value, and B is larger than 0. This is what we found in part A. This is what we found in part B. So which one is larger? We can discuss it, okay. But I want to first prove to you which one is larger mathematically. So how do you do that? It's very simple. You can say part A minus part B. If it's positive, part A is more. If it's negative, part A is less. Part A minus part B. So B times 1 minus D n sub T plus M minus 1 minus D B sub n sub T plus M. And all we have to do, distribute, simplify, and see what we get. So this one is B minus BD. Let me just do this. B minus BD. We're going to multiply by n sub T. So we get B n sub T minus BD n sub T plus M. And this one, 1 gives you the same thing. Minus D gives you minus DB or BD n sub T minus dm, and this negates everything. So here's the first one. This one is again 1 gives you the second parenthesis, and minus d gives you this one minus bd or db n sub t, and this is minus md. So we are foiling. So now this remains, this becomes minus, this becomes minus, this becomes plus, this becomes plus. These two cancel each other. These two cancel each other. These two cancel each other. We are left with MD. M is positive, the number that we added, and D is positive. So because MD is positive, mathematically, we proved part A does a better job. But why is that? I think it's pretty straightforward. In part A, all the additional fish survive. Remember, we add how many? M. But in part B, all of those additional fish are also can be preyed upon. So all fish face predation. That's why it makes perfect sense.